Hello students, under the topic integration by parts, here we have an important problem, that is to find integral e power x sin x dx. So now in this we have to apply the integration by parts, for which we have to make the choice of u and the choice of dv in this order, that is I, L, A, T, E. So if you observe, here we have two functions, one of which is exponential and the other function is trigonometric. So now if you see this order, trigonometric function comes first and the exponential function comes after that. So we have to choose u to be equal to the trigonometric function. So what is the trigonometric function here? Sin x is the trigonometric function. So that has to be chosen as u. So u is equal to sin x. And the remaining fully has to be chosen as dv. So the remaining part is e power x dx. So these two has to be chosen as dv. So dv is equal to e power x dx. And you always remember, whenever you have a combination of e power x and sin x, that is whenever you have a combination of an exponential term and a trigonometric term, you take that integral to be equal to I. So this integral is taken as I. Okay, we are representing this as I for a reason, which we will be knowing while solving this problem. So the given integral has to be represented as capital I. So instead of writing this integral, wherever we find this integral, we can represent it as I. Okay, which means the integral. So I is equal to this integral, where the choice of u is sin x and the choice of dv is e power x dx. Now we have to differentiate this u. So du by dx is equal to, what is the differentiation of sin x? It is cos x. So from this we apply we obtain du to be equal to cos x dx. So du we have obtained, u we have chosen as sin x, and we have obtained du to be equal to cos x dx. Now from this we have to integrate on both the sides. The integral of dv is v and the integral of e power x is e power x. So we have obtained v from this. Now we have to apply in the formula, integral u dv is equal to uv minus integral v du. So this is the formula for integration by parts. So in this formula, we have to substitute this u, v and du that we have obtained. Now integral u dv is the given question, that is integral e power x sin x dx. But we have represented this as I, capital I. So we can, instead of integral u dv, we can write capital I is equal to uv. What is u? Sin x. V is e power x. So sin x multiplied with e to the power x minus integral v du. V is e power x and du is cos x dx. Okay, so now we have obtained the integral I. So let us mark this as equation 1. Now in this integral we have to evaluate integral e power x cos x dx. So if we evaluate this, we will be obtaining the integral I. Now we have to find integral e power x cos x dx separately and then take and substitute in equation 1. So again this has to be done by using integration by parts, where u will be equal to trigonometric function as I told you before, and dv will be equal to the remaining function, which is e power x dx. Now from this, du by dx will be equal to, we have to differentiate cos x. The differentiation of cos x is minus sin x. Okay, from this we obtain du to be equal to minus sin x dx. So let us mark this. So this is du, u, and from this we have to integrate on both the sides to get v, which is equal to the integral of e power x is e power x only. So this is v. Now we have to again use the formula, integral u dv is equal to uv minus integral v du. So let us apply that here now. Now integral u dv is this, that is integral e power x cos x dx. This is what we are evaluating. So that is equal to uv. What is u? Cos x. V is e power x. So cos x multiplied with e power x minus integral v du. V is e to the power x and du is minus sin x dx. So this minus and this minus gets multiplied and it becomes plus, and here we have sin x dx. Now this integral, if we evaluate, again we are getting a integral of product of two functions, but we observe that this integral is the same integral that is given in the question, that is integral e power x sin x dx. So this is also integral e power x sin x dx, and what we have taken it as, we have represented this integral as capital I. So that is what we have to evaluate finally, that is this equation 1. So that capital I we have to substitute here. So this integral will become e power x cos x plus I. So this integral e power x cos x dx we have obtained to be e power x cos x plus I. Let me mark this as equation 2. Now this equation 2 has to be substituted in equation 1 for this. That is, we are going to replace integral e power x cos x dx to be equal to e power cos x plus I. So here we have to replace it as e power cos x plus I. So finally this equation 1 is what? It is I equal to, so that we will write. So I equal to, now what is this? This we can write as e power x sin x. Okay. So e power x sin x. And then what we have? Minus. So minus this integral we have evaluated here. So this is the integral that we have evaluated and we have obtained as this. So that we will substitute. So minus e power x cos x plus I. Now on simplification this will become, so I will be equal to e power x sin x and then minus e power x cos x, then minus into plus is minus I. Now taking this I to the left hand side, this negative I will become positive. So it will become I plus I equal to, now in these two terms e power x is common. So e power x multiplied with sin x minus cos x. Now from this we will be obtaining, what is I plus I? It was 2I is equal to e power x sin x minus cos x. Now taking this 2 to the right, it will go in the denominator. So therefore I will be equal to e power x divided by 2 multiplied with sin x minus cos x, and at last we will add c, because which is a constant of integration. So plus c. Now what is this I? It is the given question, right? That only we have represented as capital I. So integral e power x sin x dx. So therefore integral e power x sin x dx is equal to e power x by 2 multiplied with sin x minus cos x plus c. So this is the answer that we obtain. So if you patiently go through this problem once again, you will understand it better. We will do one more problem of the similar type. So we will do that in our next video. Thank you.